Welcome to Filtering versus Graphics, Round 3. My name is Timothy Lottis, and this is the NeoKino Graphics channel. This is going to be a short talk on micro-optimizing a filter kernel. We'll be looking at the same 1D filtering as last time in the last video. And note that 2D filtering, whether it's two 1D passes or one radial pass, would need a different analysis, but similar in theory. So in other words, I wouldn't just blanket use what I came up with this time when I actually run the thing in 2D. I would basically redo the tests. So I'll be showing an example of working kernel shape to minimize the window, while still getting acceptable output. Last time left off with a 6-pixel kernel. Can this be reduced some more? Let's find out. The thing I like to do is work in Desmos and actually graph all the kernels. So in this case, I remapped all the kernels to the same 0 to 1 window. The reason I do this is because then you can use saturate on the input to the function, and it gets really simple to implement that way. So the purple one is the magic kernel. The green one is from the last talk. It's the fast kernel. The orange one is a less tight fast kernel, and the red one is the least tight fast kernel in this example. You'll notice as the kernels effectively get wider inside this window, it means that I can reduce the window size to try to match them better. And potentially I can have a lower total cost, depending on the behavior of the kernel in practice. So next, let's look at these in practice. You can follow along on the shader toy up there. So switching to a 6-pixel magic kernel, it might do a little bit better at trimming out Nyquist. However, it is a bit softer if you look at the left side of the graph. The green line, that's the one from last time. We'll use that as the baseline. The orange line is now reduced to a 5-pixel window, and this one is faster and sharper because it's using a little bit less work. You notice that it still trims pretty decently at Nyquist. However, it allows a little bit more frequencies to come by on the route to half Nyquist frequency. And it allows a tiny bit more moire potentially, but I think this would be under what is perceptual in real world. Then the next one, the red line, that one is still using a 5-pix, but it's using the less tight window, and you'll notice that now Nyquist is starting to bleed through, and it starts trimming frequencies slightly lower than Nyquist. And if we drop that same kernel to 4-pixel, it just gets worse. So at this point, we know the best possible option is going to be that 5-pixel kernel. So if there's any theme here, it is try all the things. Managed to reduce the work by 1/6 and got a slight benefit. I personally like to try all the options until I bisect the problem. Thus have a slightly more expensive option that is beyond good enough, have the slightly less expensive option that is not good enough, and then figure out the one that's in the middle of that. That's it for today.